Good day, everyone. Okay, let us try to answer part two of the quiz that we have last time. So let us say number one. Number one, it says here a natural number is an integer. Then an integer is a natural number. Okay, which of this statement is true? Which of this is false? Okay, so a natural number is an integer. So if we recall back now in your algebra that by definition, a natural number is the natural counting numbers. No? That's 1, 2, 3, 4, 5, 6, and so on. While integer, by definition, it is the union of the set of whole numbers that is 0 and the natural numbers plus the negative of the natural number. So therefore, we could say that a natural number is under integers, but not likewise. Okay? So therefore, the only statement that is true here is number one. No? So a natural number is an integer. But number two is a false statement because there are some integers that are cannot be a natural number. Let's say, for example, negative 5. Negative 5 is not a natural number. So that's it. No? So number one, the answer is option A. Only one is true. Okay, let's have item number two. It says here a triangle has three sides and a quadrilateral has four sides. And number two, the triangle has three sides or the quadrilateral has four sides. Okay. For and or statements, okay, the statement is said to be true for and statement conjunction if uh, both statements are true and the rest is false. Both statements is true. If both statements are true, then the statement is true. If one statement is false, at least one statement is false, then the whole statement is false. For or statement, um, the whole statement is true if at least one premise or at least one statement is true. No? So if it is only false if both statements are false. Since here both statements are true, so therefore the and or statements here are both true. So the answer here is option 3. Okay, that's this one. We have an or statement, a disjunction, and a conditional statement, if then statement. So let's try to recall back. Statement is true in disjunction if at least one is true. Then in the if then statement, the conditional statement, the statement is only false when the if statement is true, then the conclusion, then statement is false. No? So if true then false, false statement yun. So since here, the statement 1, we know that 1 plus 1 is true, and monkey can fly is false. It is or, so therefore 1 is a true statement because at least 1 is true. Then for item 2, if monkeys can fly, which is false, then 1 plus 1 is true, which is a true statement. So we have if false then true, then that is also a true statement. So therefore, both statements are true. Okay. So both statements are true. Okay, let's have the next item. The next item covers um, quantifiers, no? Quantifiers, logical quantifiers. For number one statement, says here there exists x for all y such that x squared plus y squared is less than 12. Okay, we say that this is a true statement. So says here um, there exists, no? So for all y, let's say if y is 1, so we can say if x is 1, so 1 plus 1 is less than 12. That's correct. So for all y's, we are going to test it with 2. So 1 plus 4 is 5 less than 12. So that is also true. So if y is 3, let us say if x is 1, so 1 plus 3, 1 plus 3 squared, it's 9, so that's 12. So that is a true statement. So therefore, 1 is true. Then, um, for all x, for all y, so we are going to test, no, for all values of x and for all values of y. So if there is at least one that is false, then the whole statement is false. So let us say y is equal to 1. So could we say that the statement is true for all values of x when y equals 1? So let's say 1 squared plus 1 squared is equal to 2. That's the 12. So that is true. Let us say 2 squared plus 1 squared. So we have 5. 5 is less than 12. That is true. And let us say if we have 3 squared plus 1 squared is less than 12. So that is also that is 10, which is less than 12. That is also true. Now let us try to test when y is equal to 2. So let us try to test for all values of x. So 1 squared plus 2 squared, which is equal to 5. So 5 less than 12. So it's also true. Let us say if x is 2, so 2 squared plus 2 squared, so we have 4 plus 4 is 8. It's less than 12. So that is true. Okay. Let us say if x is equal to 3, so 3 squared, that is 9. 9 plus 2 squared is 4, so 9 plus 4 is 13. It's less than 12. Is 13 less than 12? So it's a false statement. So since there is at least one that is false, so therefore number 2 is false. So therefore the only statement that is true here is only 1. Okay, for last number. So let us say for A is covers the set of 1, 2, 3, 4, 5. Could uh, we say that there exists a value of x in A such that x plus 3 is equal to 10. So let us try to test, no? Let us try to test all values if nabay at least 1 na mag-equal to 10. So 1 plus 3 is 4. So false. 2 plus 3, 5. Okay, again, it is not equal to 10. That is false. 3 plus 3 equals 6. Again, that is false. 4 plus 3 equals 8. So again, that is false. 5 plus 3 is equal to 10. So that is false. So therefore, the whole statement is false. Since there is no one, at least one, we cannot see at least one that would satisfy the given statement. Okay, so let us say number 2. For all x in A, such that x plus 3 is less than 10. So for all, so dapat when we are going to test for all the values of x, dapat it should be less than 10. So 1 plus 3 equals 4, which is less than 10. That's correct. 2 plus 3, which is equal to 5, less than 10. So correct again. 3 plus 3, which is equal to 6, less than 10. Okay, that's correct. 4 plus 3, which is less than 10. The 7, which is less than to 10. So that's also correct. So 5 plus 3, which is equal to 8, which is less than to 10. So that is also correct. So therefore, the second statement is true. So therefore, the answer here is only 2. Only 2 is, again, that's it. So if you have questions, just comment it down below or type it down below in the comment box.